السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. مرحبا بكم مع منصة البث المباشر وزارة التربية والتعليم جمهورية مصر العربية. معكم مستر حسام حسن. Now session and we complete the last session of revision and solving of assessments in W5 on week 5. For this revision we focus about the central atoms and how can you write the Lewis dots model and the geometric shapes of the molecules. Now we discuss the first questions. Which of the following expresses a central atom that cannot form coordinate bonds? Now we have discussed the coordinate bonds. Before I solve these questions, I will know some things about coordinate. To make coordinate bonds, you must firstly distribute the central atom. After distribution, the central atoms, you can to define the number of bond pairs and lone pairs in these atoms. Can you write it by electronic configuration of this central atom? If you have lone pairs, so these atoms can make coordinate bonds. If you have no lone pairs, now you can to make coordinate bonds, and these atoms cannot make coordinate bonds. Okay, this questions discuss which the following express central atom that cannot form, not form, but cannot form. So these atoms have no lone pairs. Okay, this is easy to choose from A, B, C, D. In A, we have AX2E2. We have two lone pairs. B, AX3, no lone pair. C, AX2E, you have one lone pair. And D, AX3E, you have one lone pair. Now you can to know what's the true answer. Now you can to transfer in the next slides to know the solving of these questions is what? AX3. Why? Because AX3 no E. No E, I mean no lone pair in this atomic or central atom. Now X3 represents a molecule like BF3. The central atoms has no lone pairs. B, atomic number equal to 5. When you make electronic configuration of boron, B equal to 5. So the electronic configuration is 2s2 and 2b1. You have 3 electrons only. This is 3 electrons is 3 bond pairs. So it is no lone pairs electrons left after forming all bonds. So it can act as a donor. No donor center atoms in a coordinate bonds. X2E like H2O has lone pairs can form coordinate bonds. AX2E example SO2 has one lone pairs can form coordinate bonds. AX3E example NH3 one lone pairs can form coordinate bonds. Now it is easy to know. It is easy to know how can you define the lone pair and bond pair, and you can benefit from these configurations to define which one can make forming the coordinate bonds. Now, which of the following expresses the coordinate bonds in the fluoroborate ions BF4 negative? I have made many things in this table. This is option A, B, C, and D. First option, donor atom or ion boron atom donate 2 electrons from orbital sp2. Okay, you must choose firstly common by common. and you can make sign, or you can make to know which one is true from this column. Fluoride ions donates 2 electrons from sublevel 2b. Boron atoms donates 2 electrons from orbitals 2s. Fluoride ions donates 2 electrons from level 2s. Now, 2s have 2 electrons, but in this choices we have many things as sp2 hybridizations or hybrid orbital, or 2b from the fluoride ions donates 2 electrons from sublevel 2. Okay, now acceptors atom or ion. Fluoride ion accepts 2 electron in orbital 3s, or boron atom accepts 2 electron in the orbital 2bz. Fluoride ion accepts 2 electron in orbital 2s. Boron atoms accepts 2 electrons in orbital sp2. Now we have many choices. You must use firstly Coleman-Boy-Coleman to know which one the following express this coordinate bonds. You must have one is donor and the other is acceptors. Okay, to know and focus, the correct answer is what is D, because fluoride ions donates 2 electrons from level 2s. Okay, and the other, we have boron atom accept these electrons because we have an empty orbital. Okay, you must complete this slide to explain that. In BF4 negative sign, the BF3 molecule has boron with only 6 electrons. Okay, 6 electrons in complete octet. Okay, BF3, BF3. Okay, we have is not obey by octet rule. The fluoride ion F negative has lone pair, The fluoride ions donate its lone pairs from the 2s orbitals to the boron atoms, and which accepts these electrons into an sp2 hybrid orbitals after slight for the hybridizations to form the coordinate bond. Now, in these questions, which of the following bonds do chemists consider being the bonds of life and reasons for the continuations of life on Earth? Metallic bond, covalent bond, ionic bond, hydrogen bond. Okay, focus on these questions to relate between our life and the bonds in our life and the reasons for the continuation of life on Earth. What are the relation bonds between metallic bonds or covalent bonds or ionic bonds, hydrogen bonds in this session? So correct answer is D. Why hydrogen bonds? Because hydrogen bonds give water its unique properties. Okay, unique properties, high boiling points. Okay, water is a liquid. This is the water is a secret of our life. Our blood is liquid. Our brain have liquids. Our stomach have liquids. Our all devices in our human body are liquids. These liquids have an ions, sodium ions, potassium ions, magnesium ions, aluminum ions, copper ions, and so on for potassium ions, and so on for these ions. They are soluble in water. So the water is very important for our life, and plants and human people and all living organisms. So the hydrogen bonds is a secret of the water is the water is liquid state. It is not vapor state. So it is unique properties, high boiling points, abilities to dissolve many substances. This is substances, the surface tension these properties are essential for life. Hydrogen bonds also play a key roles in the structure of DNA and proteins and many things. If I discuss the slides only, I take many hours to understand this, and this is a relation between a chemistry and the biology. Okay, so now we focus only on the hydrogen bonds and the ability to make attractions between the water molecules and the secrets of our life for any living organism. Okay, okay. Now, the following table show the boiling points of hydrogen halides. We have hydrogen fluoride is 19, and we have HCl is negative 85, hydrogen bromide is negative 67, hydrogen iodide is negative 35. Now, you know the boiling point of each things in this questions. Okay. Next, which of the following choice explains why hydrogen fluoride had the high boiling points? HF molecule have a smaller dipole moment. HF is a stronger acid, or HF is a less soluble water, or HF molecules are bound by hydrogen bonds. So I have the question and I have to think for the true answer. Hydrogen is a stronger acid. Okay, that is no problem. Stronger acids, but it is not stronger acid. HF is not stronger acid. HF is a weak acid. Okay, HF have a smaller dipole moment. I discuss why boiling point. Boiling point relate with what? Okay, review with me the hydrogen bond. The hydrogen bond is essential way and basically depends on the boiling points and hydrogen bonds between molecules. So the true answer is D, which D is HF molecule are bound by hydrogen bonds. The hydrogen bonds is the regions for this binding between molecules. So HF form strong hydrogen bonds. Why strong? Because the difference of electronegativity between hydrogen and fluoride. When we teach hydrogen bond, I discussed with you before the relation between the strength of hydrogen bonds and the directions of hydrogen bonds and the difference in electronegativity between two atoms forming hydrogen bonds. Why? Increase the difference between these atoms and hydrogen bonds so the I remember. Okay, the strength increased by increasing the difference between the atoms and electronegativity. So HF forms strong hydrogen bonds between molecules because fluorine is small and high. Small what? Is a small in radius and high electronegativity. Okay, breaking these bonds requires more energy, resulting in much higher boiling points compared to other hydrogen halides, which only have weaker dipole interactions and London dispersion forces. Now, this is an example to know which London dispersions. Now, it's not our teaching now, but it is an example for interactions between these atoms. Number 5, which of the following expresses the types and number of bonds in the molecules of liquid aluminum chloride Al2Cl6? Okay, S aluminum chloride Al2Cl6 of bonds in molecule of liquid aluminum chloride. Now, 6 covalent bonds and 2 coordinate bonds, or 6 coordinate bonds and 2 covalent bonds, 3 covalent bonds and 1 coordinate bonds, 6 covalent bonds and 1 coordinate bonds. Now, you must make electronic configuration of chlorine and aluminum. You know, aluminum 13, chlorine is 70. Now, if you make electronic configuration of aluminum equal to neon 10 to S 3s2 3b1, okay, chlorine 17 neon 10 3s2 3b5. So chlorine make 1 covalent bond. Aluminum make 3 bonds because I have 3 electrons. This is covalent bonds between aluminum and chloride. Now, why Al2Cl6? I have many bonds. These bonds is 6 covalent bonds and 2 coordinate bonds. How it is make? Because Al2Cl6, each aluminum form 3 covalent bonds with 3 Cl atoms. Okay, each Cl 1, Al make 1 or 3 Cl related with aluminum. Each aluminum atoms form these 3 covalent bonds with 3 chlorine atoms. Additionally, each aluminum atom accepts alone pairs from the bridging chlorine atoms, forming 1 coordinate bonds per aluminum. Since there are 2 aluminum atoms, totally bonds equal 6 covalent bonds plus 2 coordinate bonds in this example. Okay, the atom of elements X has only 4 completely filled subshells, so a sample of these elements has bonds that are pure covalence, ionic, metallic, polar covalent. Okay, atom X have 4 completely filled subshell. Okay, so sample of these elements has bonds that are what? Pure or ionic or metallic or polar. Now, if we make electronic configuration to show this, you find that it is a metallic bond. Why this metallic bond? This atom have 4 completely filled subshells. 1s2, 2s2, 2b6, 3s2. Okay, this is complete S2. Okay, complete S2. Okay, B6. Okay, S2. Okay, discount 1, 2, 3, 4. Now, this is arranging of this subshells, but I have 3s2. It is a metal. Okay, when I discuss this metal, make a pure covalent? No. Ionics? Maybe. Metallic? Okay. Polar covalent? Maybe. Because I refuse this choice, because a sample of these elements has bonds that are metallic bonds through a sea of decollized electrons. These metals form metallic bonds. This is metallic bonds. It is to ensure that you write this electronic configuration and you think to know which the bonds make, because atom of element has, this is the properties of this X. Okay, I mean a sample of this, I sample a piece, I discuss a sample of these elements has bonds. I don't mean if I call XCl2, I know here is ionic bond, but The ask here, question here is sample of this element, a piece of this element. Now, a sample, I mean this is a metallic bond. Number 7, I have 3 organic compounds X, Y, and Z have the following chemical formulas: X, CH3, CH2, 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 CH3. Okay, this is pentane. It is no important for you to know the name of this. CH3, CH2, CH2, SOH is a 1 pentanol, and OH, CH2, 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 OH, 3 propanediol. Propanediol. Okay. Question. Where the question? Now, focus these all X, Y, and this. Okay. This is a pentane carbon with hydrogen. This is a pentanol. I have hydroxyl group. I have 2 OH. Now, which is the question? Now, based on your study of polarity and hydrogen bonding, which choice express the correct order of these compounds according to their degrees of solubility in water. Okay, if you review the slide again, now it is this compound insoluble. Why? If you review that, which bonds here, what the type of bonds here? Covalent bonds, mister. Okay, this is a covalent bond because I have a carbon and hydrogen. Okay, but this carbon and this hydrogen makes non-polar covalent bonds. Focus with me for that. Carbon and hydrogen make a non-polar. Why? Because the electronegativity difference in electronegativity between carbon and hydrogen less than 0.4. Okay, you must study that for your book to review these informations to know the relations between the polarity and the dissolving water. I mean polar soluble in polar solvent, non-polar insoluble in polar solvent. Okay, next OH, it is a polar bonds. We have 2 polar bonds. If you make ascending or descending arrangements, I have many examples. I illustrate you what is the difference between X, Y, and Z. I found here is Z is more soluble because it have 2 OH, but Y have 1 OH, and the other is X. Now, the discussion's correct answer is C, X less than Y less than Z. So Z is more soluble in water because Z have 2 OH. Now OH here and OH here. So Z is more soluble in water because number of polar bonds or polar covalent bonds is more than the Y. I have 1 polar bond and X have no polar. Now we discuss that X have no polar bonds and polar bonds. X pentane is non-polar and insoluble in water. Y 1 pentanol has 1 OH group, can form hydrogen bonds with water, but the 1 hydrocarbon chains reduce solubility. So Z13 propane diol, I mean diol, 2OH. 2OH groups can form more hydrogen bonds with water, highest solubility. So the order is X less, Y more, Z is the most. Now, element X and Y are from the third period. Okay. The properties of X is the number of valence electrons is half the number of electrons in the first energy level. First energy level has 2 electrons. Half is 1 group 1 Na. This okay. I discuss again. I mean X number of electrons in half number of electron in the first energy level. First energy level equal to the last equal 1. Number Y. Y. Its electron distribution ends with 3p1. 3p1. I mean 13. I mean aluminum. Which of the following is correct? A. Y. Its melting point is higher and its crystal is softer than X. Y. Its melting point is lower and its crystals harder than X. Y. Its melting point is lower and its crystals are softer than X. Y. Its melting point is higher and its crystals are harder than X. Before answer this question, I will discuss with you to review the other things for hydrogen bonds. No, metallic bonds. Metallic bonds. I have two metals, sodium and aluminum. Sodium have one electron only in the outermost energy level. Aluminum have three electrons in the outermost energy level. Metallic bonds depends on the number of valence electrons and the outermost energy levels. I have aluminum harder than sodium. Why? Because sodium have one electron only, but aluminum has three electrons only in the outermost energy levels. So the hardness of aluminum is more, and the melting point of aluminum is worse too. Now, correct answer is C. Why? Its melting point is lower. Why? Which Y? Y is 13 aluminum. Now, correct answer C. C. Why? Its melting point is lower and its crystal are softer than X. Now, I have X number of valence electrons, the sodium. Now, if you make this table, X, Na metals, metallic bonds, relatively soft but higher melting point. Actually, aluminum had a higher melting point than Ne. And this discussions and Na group 1A very soft, low melting points, 98 degrees centigrade. Aluminum in group 13, harder, higher melting point, 660 degrees centigrade. But the questions compares melting points and hardness. Aluminum has a higher melting point and harder than sodium. However, the option must match carefully. Now, let us check the option C. Says Y aluminum has a lower melting points and softer. It is false. The option D says Y has a higher melting points and harder. That is true. Now, corrections. The correct answer should be D. But space given stable in the on the original file. Now the answer aligns with the metallic bonds, and this bonding orders Na soft low melting points, aluminum hard high melting points. Okay, it is easy to discuss the relations between the melting point, number of valence electrons, and the hardness of the any metals depends on number of valence electrons in this metal. Now, which of the following expresses the relationship between bonds in the sample of hydrogen fluoride HF? Now, this bond between H and F atoms in the molecule is shorter and stronger than the bond between the molecules. The bond between hydrogen and fluorine atoms in the molecule is longer and weaker than the bond between its molecules. The bonds between hydrogen and fluorine atoms in the molecule is shorter and weaker than the bonds between its molecules. The bond between hydrogen and fluoride atoms in the molecule is longer and stronger than the bonds between its molecules. Now, discussion here, uh, uh, which following the relation between bonds in a sample of hydrogen fluoride, HF. HF. I have the number A, I have the bonds between hydrogen and fluorine atoms in the molecule in longer and weaker than the bonds between its molecules. Which the relations here and which is the bonds between the molecule? The bonds of molecules is hydrogen bonds between molecules, but inside the molecule I have covalent bond. Now I have in this choices explanation covalent bonds between hydrogen and fluorine with an HF molecule is very short because the electronegativity between them is very high. So the bonds is very strong. So between hydrogen and fluorine with HF, but very short and strong bond energy. 565 kilojoule per mole, 565. The hydrogen bonds between hydrogen fluorine molecules is longer and weaker than equals to 20 kilojoule per mole. Therefore, the intramolecules bonds, intramolecules, therefore the intramolecules bond is shorter and stronger. Now, I have this table in question number 10. The following table shows the degree of hardness values of three metallic elements X, Y, and Z in the third period according to the Mohs scale. Mohs scale, it is a scale for the solidity of any metal. Now I have many things X, Y, and Z. Mohs hardness 2.75, 0.5 is B, 2.5 of Z. Which of the following correctly represents the groups of which these elements belong? Now, 3A, 1A, 2A, 3A. This is X. Okay, I have which one? What is the more of Mohs scale 2.75? Okay, is X. Okay, so X is 3A because the electrons or number of valence electrons is more, so it is more solid or more hardness. Number 0.5 in group 1A, this is Y equals to 0.5, so it is group 1A. Okay, I have firstly 3A, 1A. Okay, I have 2.5 Z and 2A. Okay, I must choose the true answer for this. I have Z, A, and Y, and X. Now the answer D, if I ask that, I have asked that 3A is 3A here. It is 3A. Okay, is what X. So X here is stronger or more hard. Okay, this is Y. Y equal to 0.5, Z equal to 0.5. Now we have the third periodic elements and their Mohs hardness approximately sodium, magnesium, and aluminum. This it is easy to know the choice that. I have many essays, questions for you. Compare between CH4 and BeF2 in terms of the spatial shape of this molecule, number of ion or lone pairs, and bonding pairs. Abbreviate formula AXE. Now, spatial shape for CH4 and BF2, and this is CH4, is a tetrahedral shape. Okay, BF2 is a linear. And what is the lone pair? This is no lone pair here. But here, bonding pairs, no lone pairs here in the central atom. Okay. Bonding pairs, I have 4 bond pairs and I have 2 bond pairs. This is AX4 and this is AX2. State the scientific term. I'm sorry, scientific reasons. Dry hydrogen chloride gas doesn't affect dry litmus paper, but it is turns litmus papers wet with water to red. Why? Because HCl is gas, not acid. But when HCl soluble in waters is converted into acids, dry HCl consists of neutral covalent molecules. Okay, that don't release hydrogen ions. No hydrogen ions here, and no dissociation. But when HCl dissolves in waters, we have dissociations converting H positive and Cl negative. And HCl ionized completely because strong bonds, covalent, polar covalent bonds in HCl. So I have H bonds. It is responsible for converting litmus solution into the acidic color. It is a red color. Okay. Now I have questions. Choose the correct answer when ammonia molecules combine with hydrogen protons H positive to form ammonium ions NH4 positive. Shape changes from angular to trigonal planar and angle decreases. Choice number B. Shape changes from linears to angular and angle increase. Shape changes from the angular to trigonal pyramidal and angle increase. Shape changes from the trigonal pyramids to tetrahedral and angle decrease. Now, ammonia is NH3. NH3. When combined with hydrogen protons H positive, this is a coordinate bonds. Now NH3 trigonal pyramidal. Okay, trigonal pyramidal. When you write the table which explains the geometrical shapes of these shapes, we have NH3 has a trigonal pyramidal shape. Nitrogen have 1 lone pairs. These lone pairs of nitrogen may coordinate bonds for the hydrogen ions. Now it's converted into tetrahedral with bonds angle. So the true answer is D. Now, which of the following expresses the type and number of bonds in the ammonia hydroxide molecules NH4OH? 1 ionic bond, 1 coordinate bond, 3 polar covalent bonds, 1 ionic bonds, 1 coordinate bonds, 4 polar covalent bonds, 2 ionic bonds, 2 coordinate bonds, 3 polar covalent bonds, last 1 ionic bond, 4 coordinate bonds, 1 non-polar covalent bond. Now I have in this questions NH4, I have 3 covalent bonds, 1 polar bonds, 1 ionic bonds. So I choose B, 1 ionic bonds, okay, 1 coordinate bonds, 4 polar covalent bonds. Now I have this explanation NH4OH consists of NH4 ions and hydroxide and NH4 3 polar covalent bond NH and 1 coordinate bond N. So between NH4 and OH is ionic bonds, totally 1, 1, and have this counting all NH bonds are polar covalent bonds. Which of the following compounds can form hydrogen bond can form hydrogen bonds between their molecules. Okay, I have H2O and H3, ROH and HC. This this is compounds. I have many things. Sorry, I have H2O make and H3 make only, because H2 I have OH and NH I have ROH makes, so these bonds. Now, thank you for good listening, and now I finished our session. I will see you in next session, and assalamu alaikum wa rahmatullahi wa barakatuh.